Right, children. Now we are going to start the second chapter of this lesson. Do you remember what we learned in the first chapter, children? We learned how important electricity is in our day-to-day lives is, and also we started the topic generation of electricity. Under that one, do you remember we did an assignment and we discussed that there are different methods of generating electricity. Okay? So, commonly used methods of generating electricity. This is from where we are going to start the second chapter from, right? So, commonly used methods of generating electricity. So, remember children, there are so many methods of generating electricity. All the methods we are going to categorize under three basic methods. So when you are going to the upper grades, you will understand this better. So all the methods, there are different ways of generating electricity, right? In even our day-to-day lives, we see different methods of generating electricity. But all these methods, we are going to group under three main methods. These are the ways, right? Even though if you can't understand it right now, when we go through the lesson, you will understand this better, okay? So look at these three methods, children. Bicycle dynamo. Some of you must have seen bicycle dynamo, right? A solar cell. This is a large solar panel. Now we already discussed solar panel is made by combining a lot of solar cells, okay? And these are dry cells, right? We discussed about dry cells as well. Now, day-to-day life, we call these things batteries. But here we learn these are known as dry cells. Okay, children? Right. We'll go through them. How can we generate electricity using a bicycle dynamo? Okay. So when you consider the bicycle dynamo, children, you all are going to learn this better later, right? When you consider the bicycle dynamo, it is something like this, a bottle-like structure, right? So can you all see? This is the structure. If you observe carefully, you will be able to see this is the structure, right? So when we connect this bicycle dynamo to the bicycle, this part, this is a cap-like part, and this part can be rotated like a bottle lid. We can rotate it, right? So this should touch the tire of the bicycle. Can you all say this part touches the tire, right? So then what happens? When you pedal the bicycle, when the tire rotates, now I told you this part also can be rotated. When this tire rotates, then this tiny cap-like part also rotates, and then electricity is generated inside the dynamo, right? So if you observe carefully, if you have these type of bicycle dynamos connected to the bicycles, if you observe carefully, you will see there are two terminals, two wires coming out of this dynamo, and it is connected to the lamp, right? So when you pedal the bicycle, this tire rotates, and as this cap-like part of the dynamo also rotates, it can generate electricity, which means only when you pedal the bicycle, you will see the lamp of the bicycle lights up, right? So only if this cap-like part rotates, so when it moves, electricity is generated. Okay, in order to light a lamp, electricity should flow through the lamp, right? Electricity is generated when you pedal the bicycle, right? That happens because only when you pedal the bicycle, as this cap-like part touches the wheel, it moves, and only when it moves, electricity is generated, right? So do you know that same type of method is used in a lot of power plants, right? To run the dynamos. These type of large dynamos, which are known as generators, are present inside the most of the power plants, right? These type of large type of dynamos called generators present in the power plants. So because of the movement of these generators, electricity is generated. So that is one main method of generating electricity. Right, children? Right. The second one, solar cells. I already explained y'all, solar cells, a large number of solar cells combined and a solar panel is made. What is given in this picture is a solar panel. When there is sunlight present, or when sunlight falls onto these type of solar panels, it can convert sunlight into electrical energy. So it directly converts sunlight into electrical energy, right? So in the presence of sunlight, solar cells and solar panels can generate electricity. So this is the second method. Okay? The third method is, now these are dry cells, the picture gives dry cells. However, using chemical reactions, electricity is generated. Now you are going to learn inside the dry cells there are chemical substances present. Because of the reaction of the chemical substances, electricity is generated. Which means the third method of generating electricity is using chemical reactions. In the presence of chemicals, different chemicals react with each other and chemical reactions take place and electricity is generated. So basically cells and batteries, right? Normal day-to-day life we use different types of cells and batteries. They generate electricity using the third method, using chemical reactions. Right, children? So we are going to learn about these three methods more from hereafter using experiments as well. We'll move on to the next. So the first activity we have in this lesson is generating electricity with a lime fruit. Can we use a lime fruit to generate electricity? We'll see. So what are the things we need to do this activity? Under materials, I have given these pictures. Look at them carefully. Now, this is a special circuit present inside some greeting cards. You must have seen sometimes certain greeting cards like some birthday cards. When you open the card, it plays a music, right? That is because of a special type of circuit connected to those type of cards. Right, children? So, you need a circuit taken from those type of musical cards, okay? And then you need a small copper sheet. Copper is a type of, look at the color, right? It's copper color or brown in color, right? We need a copper sheet, a small copper sheet, right? And we need a small zinc sheet. Zinc is a silver color material. Both copper and zinc are metals, right, children? We need a small copper piece and we need a small zinc piece. And we need a lime fruit. And look at this one. This is called a galvanometer. Galvanometer is an instrument in the lab that we can use to identify a flow of electric current. Right, children? Galvanometer has a small arm. There are different types of galvanometers, right? Galvanometer has a small arm. It can move here and there, but it moves only if electricity passes through it, right? That is the speciality. So it can indicate whether electricity flows through the circuit or not because it moves. The indicator or the small arm of the galvanometer moves only when electricity passes through it, right? So we'll write the names. So the first one, circuit of a musical card. Copper sheet. Zinc sheet. Lime fruit. And we need a galvanometer. Okay, children. Circuit of a musical card, copper sheet, zinc sheet, lime fruit and galvanometer. We'll see how to do this one. Look at the method. You can see this is the lime fruit. If you observe carefully, you will see these two sheets are connected with these clips, right? Fix the two sheets of copper and zinc to the lime fruit as shown in the figure. We will label this one now. This is the lime fruit. This is the copper sheet. This one is the zinc sheet. Copper sheet, lime fruit, zinc sheet. So, fix the two sheets of copper and zinc to the lime fruit as shown in the figure. Next one. Remove the circuit in the birthday card carefully. Then remove the battery from it. Right? You have to separate the battery from the small circuit in the card. Okay? So next, connect the copper sheet to the place where the positive terminal and the zinc sheet to the negative terminal of the battery. Okay, children? So copper sheet to the positive terminal, zinc to the negative terminal. And then observe what happens. Record your observations. Then connect the galvanometer instead of the circuit and record your observations. Then you have to remove the circuit from this setup and then you have to connect the galvanometer to this one. When you connect the galvanometer again, you have to make sure galvanometer also has two sides, positive and negative terminals. We must connect the copper sheet to the positive terminal of the galvanometer and the zinc sheet to the negative terminal of the galvanometer. And we have to observe what happens. Okay, children? We'll do that activity now. Right, children. Now I'm going to show you all how to generate electricity using a lime fruit. So to do this activity, we need a lime fruit. We need a copper sheet. Look at this one. This is the copper sheet. And this is a zinc sheet. We need a copper sheet, zinc sheet, and some connective wires. We need a galvanometer and we need a musical birthday card. So first of all, we need to insert this copper sheet and zinc sheet to this lime fruit. So first you can use in a blade, you can make two small slits like this. If you observe carefully, you will be able to see. And then you have to insert this copper sheet and the zinc sheet to this lime fruit. Okay, and then you have to connect these conductive wires like this. Right, and now we are going to observe this musical birthday card. You all know that there's a small circuit inside. So actually we are going to connect these two wires to this circuit. Okay, so listen. Right, children. Now you all saw that this card can produce music. Now I am going to connect these two wires to this circuit. Then listen very carefully. Right. When I remove the wires, the music stops. Again, when I keep these two wires like this. Right. So it plays again. So which means in order to play this music, there should be an electrical supply. So that electricity is provided by this setup, which means the lime fruit and these two sheets, metal sheets, the copper sheet and the zinc sheet. Right? So by doing this activity, it's very clear that this setup along with this lime fruit and the two metal sheets can generate electricity. Right. Now I'm going to connect this setup to this galvanometer. So this galvanometer is used to measure small electric currents. If you observe carefully, you can see these indicators at 0. If this indicators at 0, it means electricity does not flow through this galvanometer. Right? So this indicator moves only if electricity passes through this equipment. Now I am going to connect this lime fruit with two metal sheets to this galvanometer. We will see what happens. Now observe what happens to this indicator. Now at the moment it's at 0. You all can see it very clearly, right? So observe what happens when I connect this wire to this zinc sheet. You all can see this indicator moves. Now I already told you that this indicator moves only when electricity flows through this setup, right? Only if electricity flows through the galvanometer, this indicator will move. I will remove this again. Now what happens? This indicator is again at 0, which means electricity does not pass through this galvanometer, okay? Again when I connect this, what happens? Now you all can see the indicator moves. So when I connect this lime fruit with 2 sheets to this galvanometer, electricity is generated. When that electricity passes through the galvanometer, this indicator moves. So remember children, now this lime fruit with these 2 metal sheets can generate electricity because these all are chemical substances, right? So in the same way electricity is generated in chemical cells or electrical cells, because inside the electrical cells there are different chemical substances and these chemical substances react with each other and electricity is generated. Right children? So you observed the experiment. I hope you remember what happened during the observations when I was doing the experiment, right? So what are the observations? We'll go to this one again, right? First we connected, when we connected the circuit of this musical card to this setup, what happened children? We could hear the music was playing, right children? And then we connected the galvanometer. What happened when we connected the galvanometer to the setup children? Do you remember what happened? The indicator, that small needle-like part or the small arm of the galvanometer, it moved, right children? We'll write these things. Right. When the setup was connected to the circuit of the musical card. Circuit of the musical card, we could hear music playing. When the setup was connected to the galvanometer, the indicator what happened to the indicator? It moved. We call this deflection or deflected here, right? The indicator deflected. Moved. Okay. When the setup was connected to the circuit of the musical card, we could hear the music playing, right? When the setup was connected to the galvanometer, the indicator deflected or moved. Now what is the conclusion? Which means what can we decide after doing this activity, children? Now even during the experiment I told you all, in order to play this music in the small circuit, there must be a flow of electricity. Music plays only if electricity flows through the circuit. Right children? And at the same time I told you, the only instance that galvanometer indicator moves is only if electricity passes through it. Without electricity passing through the galvanometer, it will never deflect the indicator. Right children? So which means we could observe the music was playing and deflection of the galvanometer. which means electricity flows through the circuit in both the instances. Right, children? So how come electricity flows through the circuits in both the instances, children? That is because from where the electricity is provided, right? It was provided from this setup, right? Only when we connect this setup to those two instances, to the galvanometer and to the small circuit, we could hear this. We could hear the music playing and we could see the indicators moving, right? So which means we can come to a conclusion that this small setup generates electricity. Right, children? The setup with the lime fruit and copper and zinc sheets generates electricity. Right? We'll write that. The above observations are possible only when an electric current flows. Therefore, the above setup made of the lime fruit copper sheet and the zinc sheet generates electricity. Okay, children. The above observations are possible only when an electric current flows through the circuit. Therefore, the above setup made of the lime fruit, copper sheet and the zinc sheet generates electricity. This is the conclusion that we can come up with. How can this setup generate electricity, children? With a lime fruit and two metal sheets, how can it generate electricity? Do you remember in the previous method I explained y'all, these dry cells generate electricity because they have chemical substances in them. Because of the chemical reactions, cells and batteries can generate electricity, right? This is also a similar instance. Okay, so lime fruit has acids and copper sheet and zinc sheets are metals. So when you insert this copper sheet and zinc sheet to this lime fruit, they react with the acid and a chemical reaction takes place, and thereby because of the chemical reaction, electricity is generated. So this is a very good example that we can show that using chemical reactions, electricity can be generated. Okay, right. So look at this one. Galvanometer is a sensitive device used to identify and measure a small current in the laboratory. I already explained this one even during the experiment, right? So galvanometer, this is a certain instrument. You can identify it is sensitive to small electric currents. There are other instruments to measure the large electric currents as well. This can detect a small electric current very easily, right? So there are different types of galvanometers. Some galvanometers, now here the calibration, the numbers are there. Sometimes it presents 0% in the corner. So when electricity does not flow through the galvanometer, indicator present like this at 0, right? Some types of galvanometers are there 0 present in the middle at center like this. So when electricity does not flow through the circuit, through the galvanometer, indicator present like this at 0. These type of galvanometers are known as center 0 galvanometers, right? 0 present in the middle, other numbers present either side, right? Okay. So here, starting from one side, the other numbers present the other sides. Okay, children. However, this is a device that can identify small currents in the flows through the circuits. Okay, children. We'll move on to the next. What do you need to do this activity? We need an insulated copper wire. Insulated copper wire means a kind of copper wire coated with another paint-like substance called wire enamel, right? So we need a bar magnet and we need a galvanometer, right? Let's write insulated copper wire, bar magnet, and we need a galvanometer. Right, children? Let's see how to do this. Okay, look at the method. While doing this one, we'll label the diagram as well, okay? Wind the insulated copper wire as a coil around a cardboard. We have to first make a coil like this using the insulated copper wire. How to do this one? So you have to use a PVC tube or cardboard and you can wind the copper wire around this tube and you can make a coil like this. Okay? And scratch well and clean the two ends of the coil. I told you insulated copper wires coated with another paint-like substance, right? So electricity will not pass through this substance. Therefore, when you fix the two ends of this wire, you have to scratch the ends well. Then only through this instrument, electricity also will pass through the coil of wire, right? Fix two wires to the ends of the coil and connect them to the galvanometer like this. And move the bar magnet inside the coil and record your observations. We'll mark this one, label the diagram. Coil of wire, bar magnet, galvanometer. Right? So we are going to use a center 0 galvanometer. Center 0 galvanometer, 0 is at center, right? So what do we have to do? We have to make the setup like this. Then you have to move the bar magnet in and out of the coil of wire, right? You have to move it in and out of the coil of wire, right? So you are going to observe what happens. You will realize that when you move the bar magnet inside the coil of wire, this galvanometer indicator moves to either side, moves to two sides, right? Alternatively, it will move to two sides. Okay? Then when you stop moving, when you keep the bar magnet inside the coil without moving, right? You will realize again this indicator will stop at 0, right? So we are going to do this interesting activity now. Right, children. Now I'm going to show you all how to generate electricity using a coil of wire and a magnet. So for that one, we need a coil of wire like this and we need a bar magnet and a galvanometer, right? So how to make this type of coil of wire, children? You can wind a copper wire around a PVC tube like this and you can make a coil of wire. And then you are going to connect this coil of wire to the galvanometer. Before that, we have to scratch the edges like this, because this wire is an insulated wire. To remove the cover, we have to scratch the edges like this. Right. And now I am going to connect this to the galvanometer like this. So now you all already know that galvanometers used to measure small currents. Right. Okay. Now we have connected this coil of wire to the galvanometer. Can you all see the indicator, children? It is at 0, which means electricity does not flow through this galvanometer at the moment, right? Now look carefully what happens. I am going to move this bar magnet inside the coil of wire. You all have to observe carefully what happens to the indicator of the galvanometer. Can you all see, children? When I move this bar magnet inside the coil of wire, you all can see clearly the indicator of the galvanometer moves. Right? So when I stop the movement, again the indicator comes to the 0, which means electricity does not flow through the galvanometer. Right? Only when I move this bar magnet inside the coil of wire, this galvanometer moves. Now you all know that this indicator moves only if electricity passes through the galvanometer, which means when I move this bar magnet inside the coil of wire, electricity is generated in this setup. Right, children? Right. So to observe this very clearly, I am going to show you the laboratory model of the same setup now. I am going to remove this one. I am going to connect the laboratory model of the same setup. Now look at this very carefully. If you observe carefully, you will see this is the coil of wire. Right, children? This is the coil of wire. So we can move the bar magnet through this part. Right. So observe what happens carefully again, children. I am going to move the magnet through this coil of wire. So you all can see, this time the observation is very clear. The indicator moves. So indicators moving means electricity is generated in the setup. So only when electricity passes through the galvanometer, this indicator moves. So see, again I stop the movement of this magnet. Now at the moment electricity does not flow through this setup. That's why the indicator is at 0. So when I move this one, when I move the magnet through the coil of wire, it generates electricity. Right, children? So you clearly observed what happened. As I explained you all before, when you move the bar magnet inside the coil of wire, the galvanometer indicator deflects. And when you keep the bar magnet inside the coil of wire still without moving, that indicator does not deflect, it will stay at 0. Okay, we'll write the observations. When the bar magnet is moved inside the coil of wire, the galvanometer indicator moves or deflects. When the magnet is kept still inside the coil, the indicator does not move. When the bar magnet is moved inside the coil of wire, the galvanometer indicator deflects. When the magnet is kept still inside the coil, the indicator does not move. Okay, what is the conclusion? So it was very clear, only when we move the magnet in and out, the indicator deflects. So inside the coil of wire itself, if we keep the bar magnet still without moving, what happened? Again, this indicator goes to 0, which means electricity does not flow through this. So I told you even before, the only instance this indicator of the galvanometer moves is only when electricity flows through this instrument. Right? If electricity does not flow through the instrument, this indicator also does not move. Right? So when you move the bar magnet inside the coil of wire, indicator moves, which means when you move the bar magnet inside the coil of wire, electric current is generated inside the coil of wire. That current flows through as the coil of wire from two ends connected to the galvanometer. The electric current produces here or generated here flows through the galvanometer. Right from one side to the other, it flows through the galvanometer, and that is why the indicator moves. So without moving the magnet, when we keep it inside the coil of wire, again this indicator goes back to 0, which means at that time electricity does not flow through this one. So we can come to a conclusion, when a bar magnet or when a magnet is moved inside the coil of wire, the coil of wire generates electricity. Right? Okay. We'll write the conclusion. The galvanometer indicator deflects only when electric current flows through it. Therefore, it is clear that when a bar magnet is moved inside a coil of wire, the coil of wire generates electricity. The galvanometer indicator deflects only when an electric current flows through it. Therefore, it is clear that when a bar magnet is moved inside a coil of wire, the coil of wire generates electricity. Right? We'll move on to the next. Right. So you may have understood that an electric current was generated by moving a magnet inside the coil of wire in the above activity. Are there any other instances we use this method, children? Now remember, children, we use this method, moving a magnet near a coil of wire can generate electricity. This is a main method of generating electricity. Where do we use them, children? Do you know that this is the method we use in generating electricity in bicycle dynamos and even in motors, generators, right? So large generators are used in power plants, right? So all these generators have a moving magnet. So magnet moves, a coil of wire generates electricity. Right, children? At the same time, do you remember that I explained you all how a bicycle dynamo works? We'll go to that one again. Right? So I explained you all bicycle dynamo is a structure like this. Right? It has a structure like this and it is connected to the bicycle as if this cap-like part, the top part, touches the tire of the bicycle. This is the tire. Okay. So then what happens? At the same time, I told you this cap-like part, the lid-like part, it can rotate, right? It rotates. So when you pedal the bicycle, this part rotates. So how can this generate electricity then, children? Right? So even though you can't see inside this structure, a magnet connected to this structure from here like this, right? Okay, children. So next to the magnet, there's a coil of wire like this. The dynamo does not move inside the coil of wire but very close to the coil of wire, right? So the terminals of the coil of wire are taken out like this and they are connected to the lamp. Okay, so when we pedal the bicycle, what happens? As this cap-like structure is connected, touches this tire, when the tire rotates, this one also rotates. When this one rotates, what happens? You can see now this is the axis. This is called the axis. So from the axis, this cap-like structure and this is a magnet. And the magnet are connected. So when the top structure, this cap rotates, what happens? The axis rotates, making the magnet also rotates, which means a movement. So when a magnet moves next to this coil of wire, electricity is generated. So then what happens? As it is connected to the lamp of the bicycle, the lamp can be illuminated. Right? The lamp illuminates. This is the reason when you ride the bicycle, the lamp lights up. Other times the lamp won't light up. Right, children? That is because only when you ride the bicycle, the magnet also moves. When the magnet moves only, when the magnet is still, this coil of wire does not generate electricity. We observed it even during the experiment. Right? So when you ride the bicycle, the magnet moves and then the coil of wire generates electricity and the lamp lights up. When you ride faster, the magnet moves faster and it can generate more electricity then. Okay, children, so it can generate more electricity and more light. The brightness of the bulb increases. So in the next experiments, we are going to use a small motor. So even in the small motor, a small magnet is used inside. The same theory. Right, children? So you can understand that how important this theory is to generate electricity. Okay, so you may have understood that an electric current was generated by moving a magnet inside the coil of wire in the above activity. What are the other examples instead of this activity? We will write the same method is used in bicycle dynamos, right? Motors, small motors, right? And also generators used in power plants. Generators used in power plants. Okay, children. Right, we'll move on to the next. Who's this person? Michael Faraday. An electric current is generated by moving a magnet inside a coil of wire. We already learned this one. The scientist Michael Faraday was the first to discover this. See how important this discovery is, children. Because of this discovery, we could generate hydropower, right? We could generate wind power. So, because all the power plants use these type of generators where this theory is used, right, children? So, this discovery was a very important milestone in science. Because of this, we can generate electricity easily. Right, children? Now we have completed this chapter. Do you remember what we learned in this chapter, children? We learned about different methods of generating electricity. Under that, we learned that electricity can be generated using a lime fruit and even by moving a magnet inside a coil of wire. So we are going to learn more about generating electricity in the next chapters.